When you or the software you're using asks your locally configured DNS server for information, but that server does not already have the answer, it can deal with that request in a couple of different ways. Depending mostly upon how the administrator configured that DNS server to respond to queries, it can either forward the request or it can recursively look the information up on its own. We're going to explore what both of those things mean in this video. If the DNS server is configured to use forwarder servers, then it will simply pass the request for information on to those forwarding servers, which will then either respond with an answer if they know the answer, or the forwarder server will take full responsibility for requesting the information from the root servers and will continue following through with requests to all of the servers it is referred to until it finds the answer from a variety of sources. Generally, this process starts with the root servers. Then it goes through whichever zones and name servers are appropriate based on the domain name for which you request information. On the other hand, if the DNS server you are using does not have forwarder servers configured, but that server supports recursion, then that server is going to take responsibility for recursively looking up all of the information relevant to your request, starting at the root servers and traversing through the DNS hierarchy of appropriate name servers until it has found the answer to your question. Let's follow a request, assuming your locally configured DNS server is set for recursion. You, perhaps in a web browser, make a request for corequick.com. Actually, you specifically request, let's say, www.corequick.com. Okay, your DNS server has never heard of corequick.com before because nobody's ever asked it for that information. And it is not authoritative for that information, so it doesn't have all of the information about that domain here. So it has to look elsewhere for that information. It doesn't have it locally. It isn't configured with that zone. It's not authoritative for that zone. It doesn't have any corequick.com information. So it's got to look for it somewhere else. Because it handles recursion, it can take full responsibility for resolving this request for you. And it starts by asking the root servers if they know where the .com servers can be found. And of course they can, because that's what they do. So the root server passes along this information to your DNS server. And then it asks the com servers where CoreQuick is within the com domain. Now, all of this is being passed to your DNS server, and your DNS server's holding on to this information so that it can remember it later on, right? This is very useful. The com servers, of course, know where CoreQuick is because that's how the hierarchy works, right? The com servers are authoritative for everything in the com domain, so that record must be in their database of records. They respond with the information about the name server that is authoritative for CoreQuick. And so your recursive DNS server goes and asks that name server if it knows where the www server is within the CoreQuick domain. They respond with the information about the name server that is authoritative for CoreQuick. And so your recursive DNS server goes and asks that name server if it knows where the www server is within the CoreQuick domain. Now, because the CoreQuick name server is configured with that information, right, it has to be, it can respond with the actual IPv4 or IPv6, if it's configured that way, address of the server. So the entire recursion process has completed at this point. And it's possibly the most fundamental aspect of how DNS works, right? It's kind of the whole point of the DNS distributed hierarchical database thing, is the idea here that through this system of referrals of information to recursive servers, which are trying to find answers to your requests for the location of resources on the network, those recursive servers learn a ton of useful information about the domains that you go to frequently. They can cache that information for as long as the DNS record will allow with its time to live, or TTL, and from that point forward until the local record expires, cache that answer and simply return the correct answer the next time it's asked for the same information. So the performance improvement there is amazing for local systems, and it's a great benefit to your local network to have those local DNS servers. Anyway, all devices that have to look for mappings from names to IP addresses or for services have resolvers built right in, right? These resolvers are what actually make the requests, which is why all of this can happen in the background without you ever noticing. Without recursion, the global DNS system would fall apart. Because without sharing information about the location of resources in this hierarchical system, no system would have a way of building and maintaining an up-to-date index of where everything is by name on the internet.